From above, an artificial island can look almost natural. A shape surrounded by water, a coastline, roads, buildings, trees, and beaches. But beneath that landscape is something fundamentally different. The ground was not always there. Across the world, engineers have taken material from beneath the sea, moved millions of tons of sand, rock, and soil, built seawalls to contain it, strengthened the ground beneath it, and turned water into land. Artificial islands are not a new invention, but the scale has changed dramatically. In Miami, developers were already creating islands in Biscayne Bay more than a century ago. Star Island, created through dredging in 1917, became part of a much larger transformation of the bay. In Singapore, reclamation became a national strategy for creating room for a rapidly growing city-state. And in Dubai, the artificial island became something else entirely, a global symbol of economic transformation. The story of artificial islands is therefore not simply about construction. It is about a question that is becoming increasingly important. When the land available to a city is no longer enough, can the city manufacture more? Miami offers one of the clearest early examples of the artificial island idea becoming part of urban development. In the early 20th century, Biscayne Bay was not simply a body of water separating Miami from Miami Beach. It was raw material. Dredging equipment could remove sand and sediment from the seabed and use it to create new land. Star Island was formed in 1917. Other islands followed. The Venetian Islands emerged as part of a wider program of causeways, dredging, and land development, creating new residential districts in the bay. Many of the artificial islands between Miami and Miami Beach were built between the 1910s and the 1960s. The logic was straightforward. Water occupied space. Dredging could convert part of that water into real estate, and waterfront real estate was valuable. The artificial island therefore became more than an engineering project. It became a development model. Homes could be built on land that had previously been underwater. Roads could cross the bay. New neighborhoods could be connected to the mainland by bridges and causeways. But Miami also reveals the first major warning. An island does not exist independently of its surrounding environment. Every wall, channel, and new piece of land changes water movement. Every dredging operation disturbs the seabed, and every meter of coastline becomes part of a larger system of tides, currents, storms, and sediment. The artificial island may be engineered. The ocean is not. Then came Dubai. At the beginning of the 21st century, the artificial island stopped being merely a way of gaining useful land. It became an architectural statement. Palm Jumeirah was launched in 2001 and developed as a vast man-made peninsula extending roughly 5 kilometers into the Arabian Gulf. Its distinctive form, a central trunk, branching fronds, and a protective crescent, was designed to create an enormous new waterfront. The completed island covers around 560 hectares and is now home to residences, hotels, retail, marinas, and leisure facilities. But the engineering challenge was enormous. The island needed to withstand waves. It needed stable foundations. It needed roads, utilities, and buildings. And it needed a geometry that could survive in a constantly moving marine environment. Instead of building the island primarily as a conventional concrete structure, engineers created land from sand and protected its perimeter with rock. The result was extraordinary. a coastline had effectively been redesigned, and Dubai did not stop with one island. The World Islands Project proposed 260 artificial islands arranged in a map-like configuration, transforming the idea of reclamation into an entire archipelago of planned destinations. The visual impact was undeniable, but the deeper significance was more important. Dubai demonstrated that an artificial island could become a tool of economic branding. It could create new residential districts, tourism destinations, hotels, private beaches, marinas, and perhaps most importantly, an image of technological ambition. But the same project also exposed the cost of manipulating a coastline at such a scale. Dredging and sediment movement can alter water clarity, bury marine habitats, and change the movement of coastal water. Artificial islands can create land. They can also create new environmental problems. If Dubai demonstrates the spectacle of artificial islands, Singapore demonstrates their strategic potential. Singapore has very little land. Its population, economy, and infrastructure have grown within a territory where expansion is geographically constrained. So the country began doing something remarkably practical. It manufactured land. Major reclamation began in the post-independence period, including the East Coast Project from 1966. The transformation eventually produced areas such as Marina Bay, Changi Airport, Jurong Island, and Tuas Port. Marina Bay provides a particularly clear example. Singapore began its major reclamation project there in 1971, and the final 38 hectares of land at Bayfront were reclaimed in 1994. The resulting waterfront became one of the city's principal financial, civic, and commercial districts. But Singapore's approach is different from Dubai's. The objective is not simply to create spectacular waterfront property. Reclamation becomes part of long-term national planning. Ports, airports, housing, industry, transport, coastal protection. Each requires land, and land can be created. Tuas Port illustrates the scale of this philosophy. Phase 1 involved soil improvement across 414 hectares, including 294 hectares of newly reclaimed land, together with an 8.6-kilometer seawall and deepening of the seabed for larger vessels. The important shift is from the artificial island as an object to the artificial island as infrastructure. The island is no longer the destination. It is the platform on which the city operates. Creating an artificial island is not simply a matter of dumping sand into the sea. The first problem is the seabed. Marine sediments can be soft, compressible, and unstable. If buildings are placed on poorly treated reclaimed ground, the soil can settle, sometimes slowly, sometimes unevenly. So engineers must understand what lies beneath the proposed island before construction begins. The seabed is surveyed. Material is dredged or sourced from elsewhere. A perimeter is established using seawalls, rock armor, caissons, or other coastal structures. Then fill material is placed inside the enclosure. But the work does not end when the water disappears. The new ground must be compacted and strengthened. Drainage may be installed. Weak soils may be treated. Foundations are designed for the expected settlement, and the entire island must be engineered as part of a coastal system. Modern reclamation is becoming increasingly sophisticated. Singapore, for example, has used large quantities of dredged seabed material and excavated material in reclamation projects, reducing the need for new imported fill. The fundamental principle remains simple. You are not merely building on land, you are manufacturing the land first. But every artificial island has a second side. The ocean is an interconnected system. Removing material from the seabed changes the seabed. Moving sediment changes the water. A new breakwater changes waves and currents. A new coastline changes where erosion occurs, and the environmental effects can extend beyond the island itself. Dubai provides a powerful example. Large-scale dredging associated with the Palm projects disturbed marine environments, while the new coastline altered local water movement. Concerns included sedimentation, habitat disturbance, and changes to coastal erosion patterns. Then there is the question of stability. Reclaimed land can settle. Seawalls require continual inspection. Infrastructure must tolerate corrosion, waves, and extreme weather. And climate change introduces another variable. The island may be perfectly engineered for the conditions of today. But what happens when sea levels rise? When storm surges become more severe? When extreme rainfall overwhelms drainage? When the coastline itself is moving? The artificial island therefore creates a paradox. It gives a city more land, while placing that land directly inside the environment it was trying to control. Despite the risks, the benefits can be enormous. For land-constrained cities, reclamation can provide something almost impossible to obtain naturally. Space. Space for ports. Space for airports. Space for housing, space for industry, space for parks and public infrastructure. It can consolidate infrastructure that would otherwise require valuable inland land. It can create new transport corridors. And in some cases, it can provide coastal defense as part of a wider system of seawalls, barriers, and elevated infrastructure. For Singapore, reclamation has been one of the tools that allowed a small island nation to expand its urban and economic capacity. For Dubai, it helped create a new tourism and residential geography. For Miami, artificial islands became part of the city's transformation into a waterfront metropolis. The technology is therefore not inherently good or bad. Its value depends on what is being created, where it is being created, how it is engineered, and what happens to the environment around it. Miami turned dredged material into neighborhoods. Dubai turned sand and rock into a global waterfront symbol. Singapore turned reclamation into a national strategy for infrastructure, industry, and urban expansion. Each represents a different answer to the same problem. The technology will continue to improve, but the central challenge will remain. An artificial island is never just an island. It is a geological intervention.